Hi and welcome back. Let's look at some examples of class method and static method. There were some terrible examples in the last video, so I just wanted to apologize, but I wanted to show you the syntax for those two types of method, the class method and the static method. Let's have a class here, which is going to be the basis of the example in this video, and I think it's going to be a better example for you to understand in which situations to use which type of method. We've got this fixed float class. It's got an init method in which an amount property gets initialized in the object. And then it's got a repr method, which returns a string representing the object. We've looked at this type of method, at this exact method before, and all it's doing is it's printing fixed float, the class name, and then self.amount, which is the amount that we initialized earlier. And this is an interesting Python construct that allows us to print the amount to 2 decimal places. Not 3, not 4, not 5, not 1, just 2. So for example, if we were printing 15.50, Python would normally print out 15.5, but with this construct here, it will print 15.50. So this is a fixed float, a float to a fixed number of decimal places. If we wanted to create our number and it'd be a fixed float like 18.5746, then we can print the number and it will print out that this is a fixed float of 18.57. So okay, this does something. What is a use case that this could be useful for? Well, for example, for currency, you could imagine using something like this for some currencies that are always to 2 decimal places, but sometimes they trade in the stock markets to many more decimal places in the currency markets. So anyway, it could be useful in some scenarios. Now, imagine we wanted to get a new fixed float object as a result from summing 2 floats. We could do that, we could do something like def from sum. And then of course this is an instance method, so it takes self, it takes value 1 and value 2. And what this is going to return is a new fixed float object of value 1 plus value 2. So again, maybe not something you would want to do. You could just add the values together and then create a fixed float object from the result. But let's say we want to do this for a particular reason that you'll see in a moment. Now, if we wanted to create a new fixed float object that is a result of 2 values, we could say new number is number.fromSum. Notice how we have to do number.fromSum because this is an instance method. It doesn't have any decorators on top. And it'll be something like 19.575 and 0.789. Then we can print the new number, like so. Now we get a new fixed float object, which is 20.36. That's the fixed float that has been returned, which adds up the 2 numbers together, 19 and 0.7. However, I don't really like this, because in order to call the fromSum method, we've had to first create a fixed float object that we never used. Right? We only used it to call this method. We never used self inside this method. And we never used this number anywhere else. So really, creating an object for this is not that useful. You should only create objects when you're going to use them. So instead, we could make this a static method. Remove the self, and now you no longer need the object there, which means that instead of calling it with the object, you can just call it with the class. Remember, we no longer need to pass the object in here, so you just call it with a class and don't pass the object in. And then value 1 is this, and value 2 is that. We can run it again and see the same thing comes out. So that looks a bit better. Now we don't have the useless parameter, and we don't need to create an object before we call the method. Awesome. However, let's extend this example a bit more and create a new class, which is going to be a currency class that extends that fixed float class. Let's call it Euro. And this is going to extend this fixed float class because euros are normally printed out as 2 decimal places too. Now we'll have another init method where self and amount are called. We are going to call super init with amount, And also we're going to define a new property specific to Euro objects, which is going to be the symbol, and that's going to be the Euro symbol. By the way, if you're using Python 2.7, it probably won't like this, so make sure you're using Python 3.6, as this symbol is a Unicode symbol. Okay, now we've got this here. Let's also override this wrapper method in order to return now a Euro class. Euro, and we're going to say self.symbol, self.amount to 2 decimal places. Okay, now if we create a new Euro object, which we shall do here, money is Euro of 18.786, and then we can print money out. So let's run that. You can see that we have this Euro now, which was the currency code, the currency symbol, which is pretty cool. It's a bit nicer. So we've defined this class that extends the fixed float class, and it's got its init method, and that calls the parent's init method to set the amount, and the wrapper method that overrides the parent's wrapper method to include the symbol and so forth. It doesn't have the fromSum method though. So what happens when we do that money is Euro fromSum of 16.758 and 9.999? What are we going to see printed out? I hope you guessed correctly. The Euro.fromSum method has been inherited from fixed float, so it's just going to be this one here. What it's going to return is a fixed float object. So this Euro.fromSum really is going to return a fixed float object, which doesn't make any sense. It should be a Euro object, surely, since that's what we called it with. Let's run this, and you'll see that I am correct in saying that a fixed float comes out. So we don't want that. What we want to do instead is make sure that we are returning an object of the type of the class we called it with, so that we are never faced with this bug, really. The way we can do that is by changing this static method to a class method and adding a CLS value there. Now this is the class that we called it with. If we call Euro.fromSum, Python is smart enough to include Euro as the first argument and therefore as the first parameter to this method. Then we don't want to return a fixed float, of course. What we're going to do is return CLS and use it as if it were the class, because it is. So if we call it from a fixed float number, that's going to be a fixed float. If we call it from a Euro line like here, it's going to be a Euro. Okay, let's run it. And now you can see that we get it correct, and we have the symbol and the Euro in here as we would expect. Okay, so that's really cool. When we call Euro.fromSum, Euro is the CLS. When we call fixedFloat.fromSum, fixedFloat is the CLS, which is really cool. This is one of the examples where you would use a class method. And a lot of the Python community is quite strongly against static methods as a whole. They say a static method is just a class method with slightly less functionality and no benefits. And I am tempted to agree with them. I would recommend that you use a class method whenever you want something that doesn't need self. And whenever you want to call fixed float inside a class method, just replace it for CLS. If you then inherit from that class, all the methods will still be usable in the way you'd expect, because CLS will automatically be populated from the class that you're using and not the class that you programmed in. So it just lets you make your methods a bit more generic and generally is a bit nicer. Static method, you can also call it, for example, if this is a static method as it was before, you call it in the same way, fixedFloat.fromSum, only now you've lost that reference to fixed float. So having a static method doesn't actually add anything. It doesn't make your code any simpler. Your code looks the same, but you've lost that functionality, which is the CLS. So generally, I would advise using class methods whenever possible. Or well, not whenever possible. Apologies, not that. Use class methods whenever you want to use a method that doesn't use self. Don't use static methods generally. I don't see that they are that useful when you've got class methods. However, there are a couple instances when using a static method can be interesting. And that's, for example, when you know that the class you're developing is not going to get inherited from. And in fact, when I am coding and I use a static method, it tells me that this class is not going to get inherited from. It's something that when I use a static method, it's like telling myself, it's safe to do this because I'm not going to use this class anywhere else to inherit from. Whereas when you use a class method, it's sort of telling, I don't know if this class is going to get inherited from later on. So that's the only place where I would use a static method, when I know and I want to make sure that I'm not going to inherit from that class. The fact that it's used static methods tells me that I don't want to inherit from here. You'll understand more about what I mean as we move over to future sections. We're going to use static methods a couple of times, but we're normally going to stick with class methods. Anyway, this was hopefully a slightly better example, helps you understand where to use static and where to use class methods, and exactly what they are useful for. Also remember, static and class methods can be called from the object, so you could have your object calling the from_some method, and that would be totally fine. You would just see the class of the object that called it, or you can call it with the class, and then the class is just that class too. And so what I mean by that is that this is fine. New number.from_some is fine. It's just going to see the class as the class of this object. It's not really something you should do normally though. Normally just use the class name, fixedfloat.from_some. That's a better way of going about things. Anyway, that's it for this video. Hopefully I haven't confused you any more than you were before, and it's helped a little bit. I'll see you on the next video.